Hi guys, this is Miss Scott, and in this video, we're going to talk about how we can solve right triangles, and we'll talk about what that means in a little bit here. So if you would like the bad joke of the day, here it is. What do you call someone who steals energy? Well, that would be a joule thief. And a joule here is actually a unit of energy. You may have learned about that in science class. Um, so a little play on words there. All right, so if you go ahead and find section 7.7 in your notes, the essential question that you can jot down is how can you find all the sides and angles in a right triangle? And that's what it means to solve a right triangle, is if you know all three side lengths and all of the angle measures, we say that it has been solved. All right, so let's jump into this. Before we can actually learn how to solve a right triangle, we need to talk about these inverse trig functions, and those can be used to find unknown angle measures if you know two sides in a right triangle. All right, and we're going to practice doing that in this table here, and then we're going to do a few examples where we have to figure out which of the three to use. So you may have on your calculator seen three buttons. The first one being above the sign button. It's actually the inverse sign, which looks like sine to the power of -1. So you use this ratio. In this case, we're going to find the measure of angle J here. So notice that this 24 is opposite angle J, and then the 40 here is the hypotenuse. So you might notice why we have to use sine. So we've set up ratios like this before. Sine of J is equal to our opposite over hypotenuse. And now to get rid of this sine right here, you can't divide by sine. That doesn't work mathematically. So what has been created to get rid of sine, we take the sine inverse. And just like everything you've learned in math in the past, if you do something on the left of an equal sign, you have to do the same thing on the right of the equal sign. So what happens there is that this sine inverse cancels out this sine right here, and we are left with J. And how you're going to plug this in your calculator is push second sine, and that'll come up with this sine inverse. And then in parentheses, we're just going to do 24 divided by 40. And then if you close up that parenthesis and push enter, it should give you about 36.9 degrees. So I really encourage you, while we're going through this video today, if you need to pause and go get yourself a calculator, go ahead and do that, because if you don't practice plugging this into a calculator, you're not going to learn how to do it. All right, so that's using sine inverse. You can also use cosine inverse. So still we're going to look at this angle J here. All right, got some lines showing up here. And notice now we have this bottom part is adjacent to that angle. The 40 here is the hypotenuse. Okay, so if we have adjacent and hypotenuse, that's ka and so katoa. So we're going to set up that ratio. Cosine of J is equal to the adjacent, which is 32, over the hypotenuse of 40. All right, now just like in this previous problem, we want to get J by itself. So to undo cosine, we take the cosine inverse. And again, if I do that on the left, I better make sure I do that on the right. So what happens is these cancel, and in my calculator, I'm going to plug in cosine inverse of 32 divided by 40. Close up that parenthesis. And if I do that, that is going to give me angle J. All right, so again, go ahead and practice doing that. You'll get better at calculating this stuff if you practice. And if you plug that in, turns out you're going to get 36.9 degrees, which you should. I actually used the same triangle for all three of these problems to start out. All right, and lastly, the tangent inverse looks like that. It's above the tangent button on your calculator. And for this one, we're still going to calculate angle J. Now this 24 over here is opposite. This 32 is the adjacent. And notice we have O and A, TOA, so that's tangent of angle J is equal to your opposite over your adjacent. And again, we are trying to get J by itself, so to get that tangent out of there, we're going to take the inverse tangent of both sides. All right, so this will cancel that tangent, and in your calculator, you're going to plug in second tangent to get that tan inverse, and then in parentheses, we'll do 24 divided by 32, close up the parentheses, and that will give you angle J. All right, so practice plugging that in. Does turn out that once again we get 36.9 degrees. Okay, so now let's branch away and look at three examples that are going to use these, but now we have to figure out if we're going to use inverse sine, inverse cosine, or inverse tangent. All right, in all three examples, we are going to find the measure of angle A. Each triangle is different though, so every angle A is going to be different here. So let's start with example 1. Put an arc on angle A, and then let's see what relationship these sides have to that angle. Notice 30 here is opposite that angle, and 20 is adjacent. So if you think of SOHCAHTOA, TOA, we have O and A. We're going to use tangent to set this up. All right, so if we say tangent of angle A is equal to our opposite over our adjacent. Okay, and again, we're trying to get tangent by itself. So we are going to take the inverse tangent of both sides. All right, so in your calculator, go ahead and plug in tangent inverse of 30 divided by 20. And if we do that, you'll get A by itself. Practice doing that. You should end up with about 56.3 degrees. All right. Let's try another one here. So I'll change colors so we can see what we're working on now. All right, we'll do red. Okay, so angle A again is right here. Notice the 9 is touching that angle, so that we call that the adjacent. 22 is opposite the right angle, so that is our hypotenuse. So if we have adjacent and hypotenuse, think about SOHCAHTOA. You have A and H, so that's cosine. So cosine of angle A is always equal to your adjacent over hypotenuse. And again, we're trying to get angle A by itself, so let's take the cosine inverse of both sides. And just be aware, I know I'm putting the cosine to the power of -1 after this ratio, just because I don't really have room to put it here. But when you plug it in your calculator, you have to put the cosine first, so you're actually plugging it in like this, not with the cosine inverse after. So just be aware of that, just like we did in the first three examples. All right, so if you plug that in as shown, you should end up with angle A being about 65.9 degrees. All right, let's look at one last example here. Again, finding angle A, 14 is opposite, 26 is the hypotenuse. So if you have O and H, SO stands for sine equals opposite over hypotenuse. So we will set up sine of A is 14 over 26. And let's go ahead and get A by itself, so we can take the sine inverse of both sides. These over here will cancel, so we'll get A by itself. Go ahead and plug in sine inverse of 14 divided by 26. And if you do that correctly, you should get 32.6 degrees. So I know I've probably said this 2 times already. Make sure you practice plugging this stuff in your calculator because it's not just going to like magically come to you if you don't give it a shot. All right. So that's what we're going to use in our last 2 examples here. These are going to take a little while, so if you need to take a break, go ahead and do that. We probably got a few more minutes because solving a right triangle does take a little bit of time. All right, so if you notice in number 4, all we know are 2 side measures and that this is a 90-degree angle at angle P right here. We still have to find the measure of angle N, M, and we have to find this length of NM. Okay, so we are actually, if we're given 2 sides, I always start by finding the unknown side length. So I'm going to call this lowercase p. A standard that you guys should start to get used to is that the side opposite an angle is a lowercase letter of that angle. So like this would be side P, over here this would be little n, and over here this would be little m. So we're going to use that in the next section, so it's a good idea to just get used to using those. All right, so if you know 2 sides, the first thing that I always do is find that third side using the Pythagorean theorem. So we're just going to set up a squared plus b squared equals c squared, filling in 15, 7, and p for a, b, and c. So if you plug in 15 squared plus 7 squared, 225 plus 49 gives you 274, and that's equal to p squared. We want to get p by itself, so let's go ahead and square root both sides. And the square root of 274 ends up being about 16.55. All right, so we've already found the missing side length, so now we know the lengths of all 3 sides. Still, we need to find the lengths of the angles. So this is where those inverse trig ratios are going to come in handy. All right, I'm going to get a different color just so we can see what's going on here. So it doesn't matter what angle you start with. I'm going to start with N. You can start with M if you'd like to. But now let's see how that 7 and 15 are related to angle N. So notice 7 is opposite, 15 is adjacent. And you always want to use the numbers that you're starting with if possible, because just in case you would happen to calculate P incorrectly, you'll still have the correct angle for N because you're starting with the given information, not anything that you calculated. All right, so our second step is to find angle N. So notice we have opposite and adjacent, so that's TOA. We're going to use the tangent of angle N is equal to opposite over adjacent, so 7 over 15. Again, we want to get tangent by itself, so we're going to do the tan inverse of both sides. And what's going to happen here is tan inverse is going to cancel out tangent, N will be by itself. And if you plug in tangent inverse of 7/15 into your calculator, you'll get about 25.02 degrees. All right. So now we know angle N here is 25.02. We've already found angle P, or side P, is 16.55. So the only piece of information we don't know is angle M right here. Well, if we know the other 2 angles, this one here being 90 degrees, we can find M pretty easily because we know those have to add up to 180. So let's take 180 minus 90 minus that 25.02. And if you plug that into your calculator, you'll get 64.98. So the angle M is our last piece of information, 64.98 degrees. All right, so when you're solving a right triangle, so now we know that this is 64.98 degrees, you should have all 3 sides labeled and all 3 angles labeled. All right, and every time you solve a right triangle, you're going to be finding 3 unknowns. So it'll be either 2 sides and one angle, or one side and two angles, like in this case. All right, so that's how you solve a right triangle if you are given two sides. Let's look at our last example, which now I only know one angle and one side. So in this case, we can't use the Pythagorean theorem because we only know one side. All right, so I'm going to call this side over here little a because it's across from angle A. And let's call the hypotenuse r because it's across from angle r. All right, let's start with the easiest thing. Right here, this angle T is going to be super easy to find because we know this angle is 24 degrees. We know angle R is 90 degrees. So the first step is let's do 180 minus 90 minus 24. And if you do that correctly, you should get 66. So we found angle T right off the bat is 66 degrees. All right, so I always like to start with the easiest stuff first. All right, and now let's find either A or R, it doesn't matter. I'm gonna go with A, why not? So if we notice, I'm gonna use this 24 degrees here. So remember, you always wanna start with your givens whenever possible. And angle A, this 24 degrees, and side A are opposite each other. And 33 here is adjacent to angle A. So in my second step, I'm going to find A. If I have O and A opposite and adjacent, that's TOA. I can set up a tangent ratio. So tangent of 24 degrees is going to equal my opposite over adjacent. And we can put a 1 under that. Let's go ahead and cross multiply. So 1 times A gives me A. And then tangent of 24 times 33. We can do 33 times tangent of 24. It doesn't matter. So let's go ahead and plug that into our calculator to find the length of A. And if you plug that in correctly, you should get about 14.69. All right. So now we only have to find side R. So we have this is 14.69. We already know angle T is 66 degrees. So our last step is to find R. Okay, so to find R, you have a couple of options. If you are like, yes, I want to do SOHCAHTOA because I love it, go for it. I prefer to use the Pythagorean theorem whenever possible. So since we know the legs of the right triangle, we can find the hypotenuse by using a squared plus b squared equals c squared. So in this case, we already found A. It's 14.69 squared plus the other leg squared equals the hypotenuse squared. All right, so if you plug in 14.69 squared plus 33 squared into your calculator, you're going to get 1,304.796 is equal to R squared, and then we can square root both sides. So if you square root that number, you are going to get 36.12 approximately for the length of R. And that makes sense. It should be longer than the other two sides because it's the hypotenuse. So just always be making sure your answers make sense. All right. So there's many ways to solve right triangles. The way that I'm doing it in this lesson is not the only way, because in step 3 here, I could have just as easily set up a trig ratio. If I'm like, I don't like Pythagorean theorem, I would rather do adjacent over hypotenuse and use a cosine ratio. You could have said cosine of 24 is equal to the adjacent over the hypotenuse and solved it this way. If you cross multiply this and solve, you'd end up with 33 equals R times the cosine of 24, and then dividing by the cosine of 24 is still going to give you 36.12. If you don't believe me, try plugging in 33 divided by cosine of 24. I guarantee you're going to get 36.12. All right, so there's many options with how to solve this stuff. The way that I'm doing this is not the only way, so just be aware of that. You and your neighbor might solve these all differently and still get them right. So I know this kind of here was just an extra example if that's confusing you. I'm just telling you there's many ways to get to solving the right triangle. All right, well, I appreciate you guys tuning in. I know that was kind of a longer video, but solving right triangles is a little bit longer process. So your homework for this lesson is these 2 pages here if you're doing the interactive binder. If you're not sure how to solve this stuff, you come find me, I'll help you out. Don't forget to comment if you have any concerns or questions, and subscribe to the channel if you're enjoying the videos. Or you can subscribe even if you're not enjoying them. It doesn't matter to me as long as I get subscribers, right? All right, we'll see you guys next time. Thank you for watching.